Hello my dear students, I warmly welcome you to Sriya Digital Classes. So now in this lecture we are going to discussing about definition of diagonalizable matrix, examples, problem based on the diagonalizable matrices. Okay. So for the short answer purpose, these four questions in this lecture are very important. Observe carefully. First question, define diagonalizable and give an example for the diagonalizable. Okay, diagonalizable or diagonalizable matrix. Second question, is every matrix diagonalizable? Mention the condition for the given matrix to be diagonalizable. Okay, so we have to mention the condition for the given matrix to be diagonalizable. Third question is, if capital A is diagonalizable and capital A is inversible, then we have to show that A inverse also diagonalizable. Fourth problem is, if capital A has small n linearly independent eigenvectors, then we have to show that A transpose also has small n linearly independent vectors. These four problems are very important for the short answer purpose. Define the diagonalizable matrix is also very important. At the same time, you have to mention one example for that. So let's start the answer for this problem. First of all, we are going to discussing about the diagonalizable matrix. Okay, diagonalizable, or else you can also write the word diagonalizable matrix also. Okay, first of all, a square matrix capital A is said to be diagonalizable matrix if capital A is similar to a diagonal matrix. Okay, a square matrix capital A is said to be diagonalized matrix. Okay, this capital A is similar. This capital A is similar to one diagonal matrix capital D. Okay, you know this notation is the similar notation. A negation D means A is similar to capital D, where capital D is the diagonal matrix. Whenever a square matrix capital A is similar to the diagonal matrix, then that capital A is said to be diagonalizable matrix. Similar అయితే సరిపోతుందా? So మరి what is the similar matrices condition? So you know very well, capital A is equal to P into D inverse. Okay, P into P inverse anamata. Whenever capital A and capital B both are similar matrices, capital A similar to capital B, then what is the condition for the similarity? You can write capital A is equal to P into capital B into P inverse. This is the condition. Okay, whenever B and A are two matrices, then to say that B is similar to capital A, so what is the condition? Same, capital B is equal to P into A into P inverse, where capital P is a inversible matrix. Same format only. Here we can say that whenever capital A is said to be diagonalizable matrix, it is similar. Okay, so just remember this word similar. Similar is nothing but similar matrices condition. Okay, it is similar to a diagonal matrix. Diagonal matrix always we can denote with capital D. Next point, for some inversible matrix capital P and for some diagonal matrix capital D, the diagonalizable matrix capital A is given by in this equation. Capital A is equal to P into D into P inverse. Okay, where capital P is the inversible matrix and capital D is the diagonal matrix. So then the diagonalizable matrix capital A is given by capital A is equal to P into D into P inverse. So that is the definition of diagonalizable matrix simply. Example here, if capital P is equal to 1 minus 1 1 minus 1 1 0 minus 1 0 1, okay, is a 3 by 3 inversible matrix and capital D is equal to 1 0 0 0 minus 2 0 0 0 minus 2 is a diagonal matrix, then the matrix product P into D into P inverse gives that P into D into P inverse equal to capital A. That capital A is equal to, we can write 1 3 3 minus 3 5 minus 3 3 3 1. It is a 3 by 3 square matrix. Whenever you take a inversible matrix capital P, observe carefully here in this example. To find the diagonalizable matrix capital A, we have to do the process, that is capital A is equal to P D P inverse. Already you know very well P matrix P, and we have the diagonal matrix capital D. To find capital A, we have to find out the P inverse value. Okay, but here where capital P we can obtain from eigenvectors. This one is the one eigenvector, second eigenvector, third eigenvector. Okay, those eigenvectors only columns of capital P. Here in the capital D, these diagonal elements are the eigenvalues of this matrix capital A. Those diagonal values 1, minus 2 are the eigenvalues of this capital A. Okay, so that is the point you have to notice. So this matrix is diagonalizable matrix. Already based on this problem we discussed one long question. Okay, so we have this capital A matrix. Okay, so we have shown that capital A is diagonalizable matrix in the previous lecture also. So you can go through those lectures once again. So next question is every matrix diagonalizable? Is every matrix is diagonalizable? So chudandi, not every matrix is diagonalizable. Why? Because n square or n by n square matrix capital A is said to be diagonalizable if and only if it has small n linearly independent eigenvectors. Okay, by the diagonalization theorem. Whenever if you want to say that capital A or any other square matrix, not only A, any other square matrix, to say that square matrix is diagonalizable matrix, what is the condition for that matrix, for that square matrix? First of all, we have to find the eigenvalues. After that, we have to find the eigenvectors. After that, we have to write the capital P inversible matrix. Okay, so then capital D diagonal matrix. After that only we can show that capital A is equal to P D P inverse condition, or else we can also show that P into A is equal to P into D. This condition also. If any one of these two conditions satisfies by capital A, okay, then we can say that capital A is diagonalizable matrix if and only if the eigenvectors are linearly independent. So that is the condition. Okay, వాళ్ళు ఏమన్నారంటే క్వశ్చన్ లో మెన్షన్ ద కండిషన్ టు బి డయాగ్నైజబుల్. ఓకే, ఏదైనా మ్యాట్రిక్స్ డయాగ్నైజబుల్ మ్యాట్రిక్స్ అవడానికి కండిషన్ ని మెన్షన్ చేయమన్నారు. దట్ కండిషన్ ఈస్ ద eigenvectors ఆఫ్ ద ఎనీ మ్యాట్రిక్స్ షుడ్ బి లీనియర్లీ ఇండిపెండెంట్. దట్ ఈస్ ఓన్లీ కండిషన్. ఓకే, సో నెక్స్ట్ పాయింట్ ఏంటంటే నెక్స్ట్ క్వశ్చన్ A inverse is diagonalizable అని మనం ప్రూవ్ చేయాలి. ఓకే, ఫ్రమ్ ద స్టేట్మెంట్ we have capital A is diagonalizable matrix. Okay, and that A has inverse also. Diagonalizable, capital A is diagonalizable. See here, given capital A is diagonalizable and that capital A is inversible also. Okay, that means we have A inverse. Then by definition of the diagonalizable matrix, we can write capital A is equal to P into D into P inverse for some interval. Okay, so for some inversible matrix capital P and diagonal matrix capital D. Since capital A is inversible, then we can write A inverse exists and O is not an eigenvalue of capital A. Okay, from the inversible matrix theorem, whenever capital A is a square matrix, from the inversible matrix theorem, whenever capital A is a square matrix and that capital A has inverse, then second condition from the last of the theorem is said that 0 is not an eigenvalue of capital A. We can say that 0 is not eigenvalue. 0 is not an eigenvalue of capital A అని చెప్పేసాం అన్నమాట. Okay, so that is capital A has all non-zero eigenvalues. Then only those eigenvalues you can write in the diagonal of the diagonal matrix. Okay, ఆ నాన్ జీరో eigen values ని మనం ఇక్కడ ఏం రాస్తామంటే డయాగోనల్ వాల్యూస్ గా రాస్తాం. ప్రీవియస్ గా మనము 1 -2 అని రాసాం కదా. సో దోస్ ఆర్ నాన్ జీరో eigen values. Okay, so and those non-zero eigen values only కరెస్పాండింగ్ టు ద నాన్ జీరో eigen వెక్టార్స్ వస్తాయి. నువ్వు జీరో వచ్చింది అనుకోండి, జీరోకి వీ కెనాట్ ఫైండ్ ద నాన్ జీరో eigen vector. So therefore capital A has all non-zero eigen values. Then the diagonal entries in capital D which are given values of capital A are also non-zero values. Whenever eigenvalues of capital A are non-zero, those eigenvalues only diagonal entries in the diagonal matrix capital D. Remaining entries should be equal to 0 in the diagonal matrix. Okay, so therefore in this format, therefore D is inversible. Whenever you can take the all the non-zero elements, we can say that D is inversible. D is inversible. Then by the noun theorem, inverse of a product. By the noun theorem, inverse of a product, we have A inverse is equal to PD P inverse whole inverse. So from the formula, you can write P inverse whole inverse, D inverse and P inverse. So therefore P inverse whole inverse is again P, and D inverse is D inverse, and P inverse is P inverse. So therefore A inverse is equal to, in this format, P into D inverse into P inverse. So since D inverse is also diagonal matrix, okay, so capital D is diagonal matrix, D inverse is also diagonal matrix. So therefore A inverse is equal to P into D inverse into P inverse is a diagonalizable. అంటే ఇక్కడ ఏంటంటే మనకు A ఇన్వర్స్ అనేది డయాగ్నైజబుల్ అని చెప్పాలి అంటే కంపల్సరీ మన కండిషన్ ఏమొచ్చిందంటే P ఇంటూ D ఇన్వర్స్ ఇంటూ P ఇన్వర్స్ అని వచ్చింది. యునో P అనే మ్యాట్రిక్స్ కి మనకి ఇన్వర్స్ ఉంది, బట్ D అనే మ్యాట్రిక్స్ కి ఆ ఇన్వర్స్ ఎగ్జిస్ట్ అయింది. దట్ ఇన్వర్స్ షుడ్ బి డయాగ్నైజబుల్. P is the inversible matrix and D is the diagonal matrix. Then only we can say that this A inverse is the diagonalizable matrix. And okay, so that is the condition. Hence capital A is inversible and that inversible matrix is diagonalizable. Then A inverse is also diagonalizable. Okay, for the short answer purpose, these concept oriented questions are very very important. Simple ga capital A ki condition తీసుకున్నామంటే PD P inverse అని చెప్పేసి, by using the inverse of a product condition we can apply the inverse on both sides, then you will get the required condition. A inverse అన్నాడు కాబట్టి A కి inverse apply చేసినాం. Okay, so that is next fourth condition, A transpose has linearly independent vector అని చెప్పాడు. So see here, given capital A has small n linearly independent vectors. Okay, capital A matrix is there, for that matrix capital A matrix is there, for that matrix there are number of vectors. Okay, eigen vectors, small n number of eigen vectors are there. Then by diagonalization theorem, capital A is equal to P into D into P inverse for some inversible matrix P and diagonal matrix D. Using the properties of transposes, so you can apply that A transpose. A transpose is equal to P D P inverse whole transpose. So then we can separate the property P inverse whole transpose into D transpose into P transpose. So therefore P transpose whole inverse into again D transpose. Again you will get capital D only. Diagonalizable matrix మీరు ట్రాన్స్పోజ్ అప్లై చేసినా కూడా రోస్ కాలమ్స్ అయినా కూడా మళ్ళీ మీకు డయాగ్నల్ ఎలిమెంట్స్ మాత్రం చేంజ్ అవ్వవు కదా, ఓన్లీ జీరోస్ చేంజ్ అవుతాయి. మీకు జీరోస్ రోస్ లో ఉన్న జీరోస్ కాలం లోకి వచ్చినంత మాత్రం అక్కడ there is no change happen అనమాట. సో therefore D transpose is equal to D and P transpose will be P transpose. So therefore if P transpose whole inverse is equal to Q. Okay, so ఇక్కడ మీకు ఒకటి ఉంది కదా P transpose whole inverse అనేది, ఆ టోటల్ మ్యాట్రిక్స్ ని ఐఎమ్ టేకింగ్ ఇట్ యాజ్ ఎ Q. ఇఫ్ P transpose whole inverse is equal to Q, then Q transpose will be P transpose whole inverse. ఆల్రెడీ Q అంటేనే P transpose whole inverse, మళ్ళీ దానికి ఇన్వర్స్ పెట్టినాం అనుకోండి మళ్ళీ మీకు ఇన్వర్స్ వచ్చేస్తుంది. therefore Q inverse is equal to మీకు ఏమొస్తుంది P transpose వచ్చేస్తుంది. అంటే వేరెవర్ యూ హ్యావ్ P transpose, అక్కడ మీరు ఏం సబ్స్టిట్యూట్ చేస్తారు, క్యూని సబ్స్టిట్యూట్ చేస్తారు. సో దాని ఇంటెన్షన్ చూడండి అక్కడ. సో therefore A transpose is equal to Q into D into Q transpose. So ఈ టోటల్ వాల్యూ we can consider as Q, D will be as it is and P transpose is Q transpose. So therefore it is also in the diagonalizable condition only na, diagonalizable matrix representation only na. So RHS value diagonalizable representation ఉంటే LHS value ఏమంటామంటే diagonalizable matrix అని చెప్పేసాం. Therefore A transpose is also diagonalizable, hence A transpose also has small n linearly independent vectors. And to show that the A transpose has small n linearly independent vector, the main possibility is we have to show that the A transpose is diagonalizable matrix. A transpose అడిగాడు కాబట్టి both side లో transpose ని apply చేసాం. So okay, so these are the 4 important questions regarding the diagonalizable matrix. So this is the total explanation of this lecture. I hope you understood this lecture very well. The next lecture we are coming with next properties. Make a perfect practice, prepare well. Until bye. Thank you.